So welcome everyone to the live interactive session number 4 of the course Mechanics of Fiber Reinforced Polymer Composite Structure. Today I am going to discuss some sample problems which are related to assignment number 4 and I am your TA Ananya Mandu. So let's start with the questions. The first question is, in an orthotropic lamina, the strengths are direction dependent and the number of strength parameters required to specify the strengths of a unidirectional lamina with reference to the material axis are. So the options are A 2, option B 3, option C 4 or option D 5. So the answer for this question is option 5 and these 5 strength parameters are these ones. The first one is sigma 1 T ultimate, that is ultimate longitudinal tensile strength in direction 1. Similarly, there is ultimate longitudinal compressive strength in direction 1. Then there is an ultimate transverse tensile strength and then ultimate transverse compressive strength. And the last one is an ultimate in plane shear strength. So these are the 5 strength parameters that are required when we have to specify the strength of any lamina with reference to the material axis. So there, as you already know, there are two types of axis, material axis and the principal axis. So this is with reference to the material axis. So this will be the answer. Next question is, the maximum stress criteria is slash in nature while Psi-Hill failure theory is slash. So the options are A, interactive, comma non-interactive. Option B, non-interactive, comma interactive. Option C, non-conservative, comma conservative. Or option D, none of the above. So, as already discussed in class, the failure theories are of two types, non-interactive theories and interactive theories. In non-interactive theories, there are two theories, that is maximum stress theory and maximum strain theory. Whereas for interactive theories, there are Psi-Hill theory, Hoffman failure criteria and Psi-V theory. So, why are they non-interactive and interactive theories? So, in non-interactive theory, when we talk about a failure in with respect to suppose longitudinal stress, then we suppose we use the maximum stress theory and we are only considering the longitudinal stress, then we try to find the failure with respect to only that parameter. Like the 5 parameters they talked about in the previous question. So we only consider any single parameter and accordingly we find the failure. That's why they are not those all parameters are not interacting with each other. We are single-handedly taking one parameter and checking the failure in that case. Whereas in interactive theories, this strength parameters are interactive to each other. That means at one point there can be a failure due to longitudinal stress and also due to shear. So when more than one strength parameters are interacting, that time we use the interactive theories and these are the examples. So what is asked in the question, that maximum stress criteria, so it is a non-interactive theory and Psi-Hill failure theory is an interactive theory. Next questions are all numericals. Um, so the question number 3 is, that is 60-degree graphite epoxy lamina is subjected to sigma x 60 megapascal, sigma y minus 90 megapascal and tau xy 120 megapascal. Given the strength parameters for a UD graphite epoxy lamina are, so the ultimate strength of longitudinal and the compressive longitudinal transverse stresses, the ultimate values are given. So we have to use the maximum stress criteria and assess the safety of the lamina and decide which of the following is true. So the options are A, that the lamina is safe. Option B, that the lamina is not safe and the mode of failure is shear. Option C, the lamina is not safe and the mode of failure is longitudinal tension. Or option D, the lamina is not safe and the mode of failure is transverse tension. So we have already, it is already given to us this five strength parameters. So we have to, these are the ultimate values. So we have to have the stress value such that it is between this ultimate value such that there is no such failures. So to find the stress value of our lamina, the lamina given here is a 60-degree graphite epoxy lamina. So first, the stresses in the uh, principal axis is given to us, that we have to convert into material axis. Yes, Hari Krishna.
Ma'am, I have seen a sir lesson on class on it, but share solved this in the different method, but you are showing this in different method, ma'am. It was just a little bit complex to the method to solve the problem.
Which one? Third question.
The third problem, yes, ma'am, third one. I have seen sir class. Sir have solved with this in some other way, but you are showing some other way.
What did sir like? How did sir solve? Can you like tell me more about it?
Yeah, ma'am. Sir, just a minute, ma'am. Sure, I'll check it, ma'am. Sir, I've taken the three different values, ma'am. I have not. I have served next column only on screenshot. Sir, I have sold three different values taken in center, and sir, I have divided which one is minimum or which one is maximum like that. We have mentioned, and the final step is positive. Then you have to take positive, negative like that. He will explain, ma'am.
They took a separate value and then they put it in the middle. That's what you're saying.
Yes,
That will come in the next question. See, the what you are saying is when we have to find the value of some, like we have to find the value of stress. For that, I will
yes,
show you now only. Can you see here? Here you can see there is a they're taking a S value and putting it in the middle, and then we have to see between that range. Are you talking like this?
yes, ma'am. Yes, yes. But also in previous in third problem also, the third one is sir said if it is come positive means then it will be share. If it is come negative means it will come it will not safe like that sir said. Ma'am. You can go to previous problem, ma'am. Third one. Here we can find though 1 2 equal to minus 124, ma'am. Right?
Yes.
Ma'am, it is solved only, ma'am. Here, sir said, if it is comes in positive means the answer will be some other way. Negative means it is not failure like that. Okay, ma'am, you go ahead with the class, ma'am. I'll finish after finishing. I can ask you this, ma'am.
Okay, I will put that at a point and I will recheck with what sir said. But according
Yes,
to
ma'am.
what
At
I
the exact
understand,
second of 51.1 exact minute, I have not done 51.1 minute on sir lesson. I have noted it, and that's what I am asking.
okay,
Okay, and
maybe
at the end of should we discuss, ma'am?
at the end of this discussion, I will check here and we'll
Sure.
see
Yeah.
what
Yeah.
sir has
Thank you.
said.
Thank you.
But according to
Yeah.
what I know, when we're taking a shear stress value, we will take the negative to positive and then we have to find the value in between them. But I will check what sir has said
Okay,
in the
that's
class.
it.
Okay.
Yeah, 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 yeah. Okay, okay.
Okay.
Sorry, ma'am, I'm interrupting you on taking this.
It's okay. Okay, so here we have to find uh, at the point where the lamina will go to failure. So we are given these values, the stress values in the uh, principal axis, that is xy axis, and we have to transform it into. So from principal axis, we have to transform it first into material axis. So that we can do by using the transformation matrix. So we are given the values sigma x, sigma y, and tau xy. When we will multiply it with the transformation matrix, we will get in the uh, principal axis, that is for the 60-degree graphite epoxy lamina. So we got the value of sigma 1, sigma 2 and tau 1, 2, that is 51.42, minus 81.42 and minus 124.95. Now sigma 1, that is in one direction 1, that is longitudinal direction. So the lowest and the highest value for the longitudinal stress will be the sigma 1 T ultimate, that is 1725 megapascal, and sigma 1 compressive ultimate, that is 1350 megapascal. So whenever we are talking about the stress in longitudinal direction, that is direction 1, the highest value that it can go to is the ultimate tensile strength, and the lowest is the compressive strength. And the compressive strength, we are taking it as negative, because when we are stressing it in this direction, that will be positive, and the compressive strength will go in the other direction, so we are giving it the value negative. So the first value had to be between these 2 points, that is 1725 and minus 1350 megapascal, so that it is lying there. The second one, sigma 2, is minus 81.42. Now this value should lie between sigma 2, sigma 2 tensile strength ultimate, that is 40 megapascal, and sigma 2 compressive strength ultimate, that will be minus 275 megapascal. So minus 81.42 is greater than minus 275 megapascal. So this value is also lying between that range. And the third one is the shear stress. The shear stress, we will take the value minus 95 to positive 95. Now this value is even lesser than minus 95. That's why this will be the point where there will be failure. So option B is the answer, that the lamina is not safe and the mode of failure is shear. Next question, question number 4, is that the given the strength parameters for a UD graphite epoxy lamina are, so the values are given. So using the maximum stress criteria, the off-axis tensile strength of a 60-degree graphite epoxy lamina is, and we have to find the value in megapascal. So here they're saying we have to use the maximum stress criteria, the failure criteria, and the off-axis tensile strength, and find the off-axis tensile strength. So the So off-axis tensile strength means that the value, we have to take the uh, shear stress in x direction as non-zero and other all the values as zero. So that is off-axis. Off-axis means that in the x-axis. So here we will take sigma x as non-zero and all the other shear stresses as equal to zero. Now it is a 60-degree graphite epoxy lamina. So we have to transform the uh, shear stress from, so we have to change the shear stress from the uh, uh, material axis to principal axis. That is, we will use the transformation matrix and multiply it with the global axis values, and we will get in the direction of the lamina. So as the angle is given 60 degree, we can get the transformation matrix, and we will multiply it with the shear stress in x direction, and other all the stresses are equal to 0. So here we have to find the what will be the value of this stress. So we will take the stress value sigma x as equal to s here, and this is the value of stress in direction 1, direction 2, and shear stress in 1, 2 we will get with respect to the value s. So sigma x value we are taking at s, considering s here. Now we have to find this sigma value within the range of the ultimate values. For that, we will put this value between the ultimate values. So, ultimate values in direction 1, that is longitudinal direction, will be minus 1352, 1725. And for the transverse direction, it will be minus 275 to 40. And for shear stress, it will be minus 95 to positive 95. So, from that, we will divide these values from the both the sides, and we can get the range of S. Now, we have to find the what could be the maximum value of this S, that is what will be the maximum stress value. Now for finding the maximum value we have to choose which will be, have the lowest value here. So here you can see the lowest value is 53.3. Why we are taking the lowest value? So that if the stress value is this, then there will be no failure. But if the stress value gets higher than this value, then it might not have fail in this criteria, but in this criteria it will fail. So that's why we have to consider whichever value is the lowest. So that will be the maximum stress value that this lamina can withstand. Otherwise, it will fail first in this transverse direction, and later it will go to the shear and then the longitudinal. So to find the maximum stress that a lamina can withstand, we have to find the lowest value. The next question is, given the strength parameters of UD graphite epoxy lamina are given. So using maximum stress criteria, the off-axis shear strength of a 60-degree graphite epoxy lamina is. Now, like the previous question here, they have they have to find the off-axis tensile strength, that is sigma x. Here they're considering the shear stress as non-zero and all the other values as zero. So again the same criteria like before, we will use the transforming matrix and multiply it with the stress matrix, where tau value is the unknown one, and then this sigma 1, sigma 2 and tau 1, 2 values we have to put between the range of the ultimate values, and from that we will get the value of tau. Now shear strength, again we have to find the lowest value. So for that we have chosen. So here we have chosen the highest value in the negative side. So maybe that's what Hari Krishna was talking about. That for shear strength, there is a significance between the negative and positive term. Which one we have to use? So I will check it once again. Why for the shear we are considering the maximum in the negative direction and not the minimum in the positive direction. So when we are talking about shear, the condition might be different. So that uh, I will suggest that you check it once again. Okay. The next question is, given the strength parameter for a UD glass epoxy lamina are given. Using Psi-Hill failure criteria, the off-axis tensile strength of a 60-degree glass epoxy lamina is. So for Psi-Hill failure criteria, the equation is given. Sir already taught this equation. So we have to put the values in this equation and consider it less than 1. Suppose so here we have to find the off-axis tensile strength, that is sigma x. So we have to find the value of sigma x. We will consider the value of sigma x as s, and all the other values, that is sigma y and sigma and tau tau xy, as equal to 0. tau xy equal to 0, and then we'll consider sigma x as equal to s and use the transformation matrix because it is for a 60-degree glass epoxy lamina, and change it from the global axis to the particle axis, and then we will put all this value in the particle axis in this equation. So sigma 1 is 0.25 s square, sigma 1, sigma 2 and tau 1, 2 values are known, and these ultimate values are also known to us, and that all has to be lesser than 1. So when we will put those values in this equation, we can find the value of s. So that will be the off axis tensile strength. Next question is a similar one, but here they are talking about off-axis shear stress. So again, here we will take the shear stress as equal to non-zero and all the other stresses as equal to 0. And from that, we will put the value with respect to shear stress as tau and equate it equal to less than 1. And from that, we can get the value of shear stress. Next question is longitudinal and transverse coefficient of thermal expansion for a UD glass epoxy lamina are. So the value of alpha 1 is given as 6 into 10 to the power minus 6 per degree Celsius and alpha 2 equal to 20 into 10 to the power minus 6 per degree Celsius respectively. For a 90-degree glass epoxy lamina, effective coefficients of thermal expansion in the global axis are. So we have to directly find from the material axis in the global axis. So we will use the transformation matrix. So this is the transformation matrix. Then we will multiply the transformation matrix with alpha 1, alpha 2 and considering the last one as 0 because the expansion will be in one or two direction, that is longitudinal and transverse direction, that is given to us, and the in the shear direction is taking as 0. When we will multiply it with the transformation matrix, we will get the values in the global axis, and that's what they have asked in this question. So this is a direct question, just we have to transform it from principal axis to global axis. Next question is longitudinal and transverse coefficient of thermal expansion of a UD carbon epoxy lamina are. So it is like the same as the previous one. Here, the alpha 1 and alpha 2 values are different. That is alpha 1 equal to 0.88 into 10 to the power minus 6 per degree Celsius and alpha 2 equal to 31 into 10 to the power minus 6 per degree Celsius respectively. Now here you have to find it for a 45-degree carbon epoxy lamina, the effective coefficients of thermal expansion in the global axis. So similar to the previous question here, again you have to multiply alpha 1 alpha 2 value with the transformation matrix with the angle given as 45-degree, and from that you can get the value of the uh, coefficient of thermal expansion in the global axis. And the last question is question number 10. The longitudinal and transverse coefficients of thermal expansions for a UD carbon epoxy lamina are, the alpha 1 is given as 0.88 into 10 to the power minus 6 per degree Celsius and alpha 2 equal to 31 into 10 to the power minus 6 per degree Celsius respectively. A carbon epoxy lamina having E1, E2, G12 and mu12 values given is heated from 30 degrees Celsius to 80 degrees Celsius. If the lamina is fully restrained, the stresses induced in megapascal in the material axis are. So first of all, the condition here given is that the lamina is fully restrained. Fully restrained means that there is a strain. Fully restrained means the strain is equal to 0. That is, there will be no strain. Now, the value of strain, the equation for strain is this: when there is normal stress occurring plus there is a thermal expansion. So, for that, the equation for strain is equal to the compliance matrix multiplied by the stress plus alpha into del T. So alpha is the thermal expansion coefficient. Now it is given that it is a fully restrained. That means the strain value, epsilon value will be equal to 0. So we will put this value as 0. From that, the stress value, stress in xy will become the the inverse of the compliance matrix into minus of alpha and delta t. Now inverse of the compliance matrix will be the stiffness matrix, and to find the stiffness matrix we are already given the values of the engineering coefficient. So we have given the values of E1, E2, G12 and mu12. From that we can form the stiffness matrix, and from stiffness matrix and the value of the alpha x, alpha y, alpha xy and delta t, we can finally find the value of sigma x, sigma y and tau xy. Now after we found it in the values in global axis, we can turn it into material axis by multiplying it with the transformation matrix. Okay, so this when you will follow these steps, you can finally get the value of sigma 1, sigma 2 and tau 1, 2 as option E. So we have started with this equation of strain, and then we put the condition that the lamina is fully restrained. That means the value of epsilon will be equal to 0. From that we have to find the value of stress. So stress will be equal to the inverse of the compliance matrix multiplied by minus alpha delta t, and the inverse of the compliance matrix will be the stiffness matrix, and to find stiffness matrix we are given the engineering constants. Putting those values here, we can get the value of stress in the uh, in the global axis, and from global axis we can turn it to material axis by using the transformation matrix. So doubts, all the questions in the assignments are similar to what been discussed right now. So do you have any doubts in the latest assignment? After that we will see the condition of the shear stress, what sir had taught. Maybe I missed that part.
Clear one, clear. No doubts.
Okay. Mm. Okay, so I checked with the video what sir taught. Sir said that if the according to what is the value, you have to consider negative or positive. Okay.
Yes, that's a small doubt. Yeah.
So here in this equation, when you will transform it using the transformation matrix, you will get the value of tau 1 2 in negative. So that's why you will, when the value is given in negative, that's when you consider the negative side. And when it is positive, you will consider the positive side. That's what sir meant. But basically, it means that it has to stay in the range this minus tau 1 to 2, positive tau 1 2. But just to
But
simplify,
it wants a
just
range. Oh,
just to
okay, okay.
simplify, he said that easier that you consider if it is negative you will take only consider this side, or if you take positive you consider this side. That's what he said. But in general it means that it should stay between this range. So that will be, you can say that it will not be failing. So that's what sir meant.
Yeah, okay, okay, okay.
Okay.
Ma'am, one more thing, ma'am. Can you share last assignments detailed for me?
Last assignment,
It is,
assignment.
ma'am, it is little bit difficult to solve the problems, ma'am. We need a step-by-step problem solving in words for it.
I didn't understand what you're saying. Do you want the sample problems for assignment number three?
Yes, ma'am. Assignment number three, the step-by-step procedures, ma'am. It is a little bit difficult to solve the matrix problems and all, ma'am. We have studied very long before that, but now it is very critical to solve those matrix problems. Can you send me those step-by-step solving details? Have any?
Step by step, I can't I don't have step by step solutions. But those are normal matrix multiplications. You can like Google it and find videos of solving those. Like the
It
basic.
was normal for. It was normal for you, no, but while seeing it was too hard for us. That's what I'm asking.
Can you give an example which what is giving like being difficult for you? Like, is it something from the sample problems of assignment three? Should I open the PPT of assignment three?
Yes, ma'am. Open. I can
Okay, I will open and you can tell me which question you are having problem.
Assignment three. That last question, ma'am. Yeah, this one.
This one.
I understand how. Yes, ma'am. This one. I understand how to solve. I understand, ma'am. But step
Are
by
you
step,
having
it will be useful for me.
trouble with the multiplication of matrix or this
Yes,
equation?
matrix multiplication.
This equations.
Equations also I understand, ma'am. But on multiplied matrix, I'm doing some errors on it.
See, this is if you want to know how to multiply this. So this first term will be multiplied by this plus the second term multiplied by this plus the third term multiplied by this. So that will give the first option. So in matrix, what happens? If they are multiplying two matrices, so suppose this first matrix is cross three. That means there are three columns and three rows. In the second
Yes,
matrix, there is only one column and three rows. So we will always write the matrix in terms across columns. So here it is 3 cross 3, here it is 3 cross 1. 3 rows, 1 column. So always multiplication first step is to see that uh, uh, is this screen visible?
yeah, visible now. Yeah.
Inverse
Then it
maybe,
will be
but
comes around three into. I understand that the first one is and the last one will be form a matrix, right?
So you have to write whenever you are multiplying matrix, it should be such that the second term of the first matrix and the first term of the second matrix they should be equal. Like here, the 3 is common. That means it is
Yes,
multiplicable.
yes, ma'am.
Then we can multiply. So when we will multiply these two matrices, the final matrix we will get will be in the form 3 cross 1.
Three, one. Yeah.
That is the first term what is
Yes,
left
ma'am.
and the last one left. So 3 cross 1, that is
Ma'am,
3 rows, 1
yeah,
column.
that. Ma'am, it's very basic, ma'am. I understand it. What I'm asking
So
is,
in that form only you
you
did
are
here.
giving some problem. Yeah, yeah. That side you are saying is very clear to me now. You have given different different term numbers, ma'am. But in actual problem, there is some different numbers. So by solving this and that, I'm getting some wrong answers, ma'am. I'm doing some wrongs. That's to clarity. I'm getting asked you to any step by step solve the solution for it.
Uh, Step by step will be difficult, but it is better that in the discussion, if you are having, like, you can share what you have solved in the discussion panel, then other TAs and everyone can see and they can correct you maybe. Or you can give me your email ID, and I will send you my email. You can send me your solution, and then it will be easier for me to point out where you are having the error. Okay.
Yeah, okay, ma'am.
So it's better you give me your email ID here. I will mail you, and then you can send me your
Yeah,
solutions,
ma'am.
and I can point out where you are getting the error. Okay.
Yeah, ma'am. Yeah.
Can you type your email ID in the message?
It was not open, ma'am.
Okay, you can spell it, then I will write it.
Hari Krishna,
Hari Krishna.
KRI, Krish, KRISH, Krishna,
Krishna?
at VEL,
Huh?
at, at VEL, VEL,
VEL.
yeah, at VEL,
Dot AC dot in.
huh?
Uh, is it this one?
No, Hari Krishna, VEL, HIGH,
Okay, it's very big.
HI,
You can't type it here.
yeah, ma'am, right, I'll type.
Okay, I will mail you in this after some time. Then you can send your like what calculation you have done. Then I will be able to check it. Okay.
Okay, ma'am.
Yes, Atul, you have joined very late.
Good evening, ma'am. Just now I came from working, madam, so I came late.
Okay, then, Hari, if you don't have any doubts, then you can leave. And Atul, I can repeat the session again for you.
No problem, ma'am. Last time I had seen the your lecture. Video, it's fine. So I'll see the recorded video, ma'am.
Okay, fine. Do you
No
have
problem.
any doubts in like assignment number 4 that you particularly want to discuss?
And no, ma'am. I've gone through sir's lectures, and I feel I can do it too. I have done almost. I'll just go through your tutorial, and if something is there, I'll send mail, madam. To done.
Okay, okay,
Thank you, madam.
okay. Fine. हो गया रिकॉर्डिंग चल रहा है अच्छा नहीं हुआ और इतने सारे लोग थे मुझे टेंशन हो गया तो मैं ठीक से बोल नहीं पा रही टेंशन क्या है इसको तो हमेशा करती रहती है पता नहीं वो उधर वो लोग थे तो मेरे को लग रहा था कि वो कुछ गलत बोले थे वो लोग बोलेंगे मैं वो परफॉर्मेंस कंप्लीट करी बहुत ज्यादा लोग थे इसलिए चित्त मच्छर है 6 सेकंड 6 सेकंड लगे से सॉल्व हुआ चलना है अभी भी 8 मिनट है हाँ मतलब वही 6 से 8 होता है बच्चे नहीं है